So for the next video lesson here, we are now looking at trig graphs, trig functions, graphing these guys. So the main idea on this you have to come back to is all these are based on the parent function. And so for any of these graphs, sine, cosine, or tangent, you need to be familiar with the parent function graph in order to do all the transformations that you might have to do for any of the changes, the extra numbers that are thrown in. So quick review on these. Here's your sine graph. Here's some of the basics about a sine graph. So sine graphs typically start at the origin. So this is what we call right here is the midline of the graph, is right here through 0. And a sine graph would normally start on the midline. It then uses the amplitude to proceed from there. And so this we get the amplitude, back to the midline, amplitude, midline, and then that can keep on going forever and ever and ever. But that's the general pattern for the sine graph. It goes from 0 to 2 pi. That's one full period of the graph if there's no other numbers thrown in. This is where the x-intercepts would occur. Again, that's anytime, if you consider your unit circle, anytime this would equal 0, so we'd say the sine of what number or what angle equals 0 in terms of radians. For this guy, and all these will be in terms of radians for these graphs. But we'd say, well, where are my y coordinates 0? Remember, sine is your y coordinate. So we'd say, where are the y coordinates 0? Right, those are 0 at 180 degrees or pi, and then back again at 360 or 2 pi. Right, that's where my y coordinates are 0, so that's where you get those x-intercepts. This from 0 to 2 pi is a unit circle. If you took a unit circle and laid it out straight like this, right, these are where those numbers occur on the unit circle. So for example, you'd have this coordinate right here at pi comma 0 would be on the unit circle. So same thing right here, you have 2 pi comma 0 on the unit circle. Or you could say I have right here, this would be pi over 2, 1 is a point on the unit circle. So for a sine graph, right, that's exactly where you would find this point on the unit circle. So down here again for the cosine graphs, again you're looking at the parent function graph when we get to some of the transformations here in a minute. So again, this is where the cosine graph does. The cosine graph typically starts off the midline. So here we have the midline in the parent function again at y equals 0 is the midline, and a cosine graph will start off the midline. So we start with the amplitude, then go to the midline, amplitude, midline, amplitude, and that continues on and on and on forever. And again, if you were to lay out the unit circle straight and just look at the cosine values, which are the x coordinates, these are where those would fall on the unit circle. So look at if you looked at the unit circle, you have the point 0, 1. So 1 is the result for 0 on the cosine value for the unit circle. So anyway, these are all the cosine representatives here from the unit circle is what creates that graph from 0 to 2 pi. Same period. And one thing I want to point out on this one, x-intercepts, remember x-intercepts occur anytime y is 0. So if I were to set the cosine of x equal to 0 and solve that, so we're saying, okay, where are my x coordinates 0? Well, on the unit circle, your x coordinates are 0. Those occur straight up at pi over 2. You would have a x coordinate that's 0. And then if you travel on the unit circle, again, if you went to 3 pi over 2, that would also be where you have an x coordinate of 0. And so that's what creates those x-intercepts that you have right there. And those matter when you look at the tangent function because, remember, tangent is sine over cosine. Remember that when you have a fraction like sine over cosine, your denominator can never equal 0, or you have a fraction that's not possible, or an undefined fraction. So if tangent is sine over cosine, we'd have to say, well, anytime the cosine is 0 is a number I can't use, and that's what creates your asymptotes. for the tangent function. So if you notice that the x-intercepts here, the zeros of your cosine function, create the asymptotes for a tangent function because they create a zero denominator when you do sine over cosine. And so that's these dotted lines that you see come from the x-intercepts of your cosine function. Tangents are a little different. They have a period of pi instead of 2 pi. So if you're ever doing a period of a tangent function, you do pi over b, whereas sine and cosines, you do 2 pi over b to get their periods. So there's just some reminders, a couple ideas with transformations that we did back in chapter 1 for what these guys tell you. So let me kind of go left to right here. A has to do with your amplitude and the range of the function. So this is how high up and how low you go within the graph. And all that is related to the center of the graph, or the midline, which is your D value. So D represents the midline of the graph. So this is our vertical shift. So remember, when you have a normal sine or cosine graph, your midline is at 0. And so if you add in some value here for D, that's going to shift your midline up or down to some other location. And then this is how far above the midline and how far below the midline you travel. B has to do with the period of the graph. It's also your horizontal stretch factor. So A and D affect your graph up and down. Right, this is your vertical stretch, and this is your vertical shift. B and C have to do with the horizontal elements of the graph. So yes, the period is 2 pi over b, but the other way to look at b is it's your horizontal stretch factor. Remember that your horizontal factors always kind of do the opposite of what you would think. That was something we saw back in chapter 1. So if this is a value of 2, then my horizontal stretch would be 1 over 2. And so I would essentially be multiplying all of my x coordinates by 1 over b. Whereas on this is your shift left and right horizontally. So this also does kind of the opposite of what you would think. If you had something like plus 3, we would go left 3 for this. If it was minus 3, then you would go right 3 for this guy. One way to deal with these when you're doing their sine and cosine graphs is just apply these to the coordinates of your parent function. So if my parent function has whatever coordinates they are, I can multiply 1 over b to the x coordinate, as well as add or subtract my c value to the x coordinate. Whereas my y coordinates, I'm going to add or subtract d and multiply them by a to my y coordinates. So look at a couple examples with me here. Min, max, periods of the graph, all those things. You can take a look at this. This is all pretty straightforward. One thing I want to point out to you, when you do a min or a max, remember that is the use of the amplitude from the midline. So this one does not have a plus d value, so it's centered at 0. So I'm going to be going 2 units above that and 2 units below that for my max and my min. Compared to this one is centered at 3, and my amplitude is 1, so I'm going to be going 1 unit above 3 for my highest point and 1 unit below 3 for my lowest point. And so that's where you get the max and the mins for those. But take a look through the intercepts and the other things within this that's laid out for you. Those are worth noting, but let's look at a couple sketches here. So again, all these are based on a parent function sketch. And so if I was going to do a cosine graph, I would just apply these transformations to the parent function. So if you just look at the ordered pairs for this, so there's always 5 key ordered pairs within one period of a graph. So 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi comma 1. Those are your 5 ordered pairs. So if I just apply this to those numbers, I get the new period of the graph. And so for this one, if I were to add 3 to my x coordinates, and if I were to multiply 3 to my y coordinates, then I would get this new look that you see right here. So from here all the way to here are the results of taking the parent function ordered pairs and adding 3 to the x's and multiplying 3 to the y's. And that gives you this new look that you see right here. And of course that pattern continues. So I can then just repeat that as many times as I need to go on with this graph if I need to keep on going for whatever the directions ask me to do. So remember what happened if you look at the parent function. It was shifted right 3 units, and it was also vertically stretched 3 units. And so it was normally went from 1 to -1. Notice it now goes from 3 to -3. Everything was also shifted to the right 3 units. So this guy right here that started at 0 was shifted to the right 3 units. Remember, pi is about 3.14. So if I shift that to the right 3 units, that point is going to move to about here. Looking at the sine graph, again, all based on just the parent function for this. So for this one here, we have a vertical shift of 2 units. So the center or the midline is being shifted up 2. For this, if I did 2 pi divided by 1/2, I get the new period for this sine function. So that's something to keep in mind. But if I just apply these to the original coordinates, so again, your original coordinates are 0, 0. This would be pi over 2, 1. This is pi 0. This is 3 pi over 2, -1. And this is 2 pi 0. And if I just take those 5 coordinates and I multiply the x coordinates by the reciprocal of this, so I'm going to multiply my x coordinates times 2. I'm going to add 2 to my y coordinates, and that's going to give me all the new values that I would need for this graph. And then I'm just going to sketch it within the proper domain, and usually that should be identified within a problem. They might say sketch the graph from 0 to 2 pi or whatever, and so you make sure that you stick with the domain identified within the problem. Last one. This kind of applies everything, so make sure you go through this problem. But if we're going to make a sketch on this, again, one way to do this is just to take your parent function of cosine graphs, take a look at the xy ordered pairs of your cosine graph, and just apply the numbers to those numbers. So again, one way to look at that is to say, okay, let's just look at the x coordinates for a minute. What are we going to do to those? Well, we're going to add 4 to those. We're also going to multiply them by 1 over 3. And so we're going to apply those concepts to the x coordinates. The y coordinates, we're going to do 2 things to those. We're going to double them. We're also going to add 1 to those. And so we're going to do those to the y coordinates to get all my new values. And that's one way to make these sketches, is just apply those to the coordinates of your parent function and you get all the new values. Or if you just deal with the transformation, basically outline the parent function graph and then apply all the transformation values. So if I just were to sketch a graph of the cosine graph, I'm going to shift it up 1 unit. So my midline is now going up 1. From the midline, I'm going to be going 2 units above it and 2 units below that for my max and my min values. My period is going to be 2 pi divided by 3. And that gives me 1 full period of the graph. I'm also going to shift everything to the right 4 units. And I'm going to shift them to the right. I'm also going to multiply them by 1 over 3. And that's going to give me all my new coordinates from that parent function graph that we had for cosines. You can graph these on your calculator, so give it a try. Put your calculator in radians, go to y equals, and sketch that graph under y equals. Go to the window of your calculator. There's a button that says window. This is your domain. So set the window. Your x minimum would be 0, and your x maximum would be 2 pi. For the y min and max, right? Well, if I'm centered at 1, and I'm going to go 2 units above 1, so 3 would be my y max. And if I'm centered at 1 and go 2 units below that, then -1 would be my y minimum. So set your window to those settings and then hit graph, and you should get the same graph that we're sketching. So give that a try. Let me know if I can help you with any of this calculator stuff or whatever. Please come on in.